It's Wednesday, January the 30th, and what we have here it's a 6100 board configured for an AC controller, just as instructed to ICT. Um, we have the same working parameters. We have both modules EP1024-1, and the board is configured for 4 to 20 milliamps for SIG high, and the delay angle is the specified 34.8, or is it 34?
34.8.
34.8 and a 100K, which is basically the 16 to 168 plus minus 2 degrees. When we power the board with 100, you're powering with 120. What we should have is the 3 LEDs solid, and this is again part of the problem that we have, because the reported failure is that you have LEDs that are flickering. That is a problem associated to the board, and that problem will stay whether the board is configured as an AC controller or as a DC rectifier. So we will have to go back and take a look at that. But the board has to have 3 solid LEDs, and that's what we have right here. So let's go ahead and bring in the 3-phase 480, and what we're going to be looking here is we have the AC input, the corresponding AC output. We have the 4 to 20 milliamps. As milliamps, we notice that we're coming into the source. Oh, here we're coming into the source with a 0 to 5, but we are actually looking at the corresponding 4 to 20 milliamps. We're bringing the positive from a power supply into SIG high, and the negative it's going through a meter as an ammeter, reading the 4 to 20 milliamps and going to common. And then here we have test point 5, test point 3, and we're going to be looking at the output both with a meter and with oscilloscope, just to verify that there's no jumps. So let's go ahead and bring in the 480. So now that we have the 480, again, the phase loss is completely cleared. Now we have the board inhibited. That's just because Tony has the board inhibited. So go ahead, Tony. So the board is cleared, and we notice that with the 0, and there's no current. Keep in mind that this is 4 to 20. The input is 477, and the output is 4 volts. And again, I said that's fine. That's very little voltage. If needed, we could always bring that close to 0 by increasing the delay angle, but this should not be a problem. And as we can see here, the output, this is part of what we see here. The delay angle that we're measuring between TP3 with respect to TP5 is approximately 163 degrees, the way we have it. So I'm going to ask Tony to use the power supply while not looking at the output of the power supply, but the 4 to 20 milliamp signal. And I'm going to ask to go at 4 milliamps, which should correspond to approximately 1 volt. So we've got 1.1, we have 420 milliamps, and we can see here our output. And you notice that we are already at 56 volts, and the delay angle has been reduced to 132 degrees. Alright, Tony, so go ahead and go 4 to 20 slowly, Tony, while Miguel and I look at the output here on the scope, verifying that we don't see any sudden changes. We can see that again, this is going smoothly, and then eventually you get your full sinusoidal output. You want to go ahead and bring it back, Tony? And this is just really a function of Tony dialing or adjusting the output of that. Can you go back again, up and down? And it's important that here we look at the triggering on test point 5, which is the most stable signal. Now the other thing we want to do the last time, okay, let's take a look at the meter. Go ahead, Tony, and try to bring it as smooth as possible. So we notice that the output it's coming relatively smooth. Alright, this is the end of this first video.